Welcome to a critical look at the biological underpinnings of depression. It's more than just a mood disorder. We are shifting the perspective. Depression should be viewed as a chronic inflammatory and immune disorder with neuropsychiatric manifestations. The core mechanism in depression is the persistent activation and dysregulation of the hypothalamic pituitary adrenal, or HPA, axis. This activation creates a cascade, starting with increased CRH in the hypothalamus, which boosts ACTH from the pituitary, ultimately leading to chronically elevated cortisol from the adrenal cortex. Despite high cortisol, immune cells develop glucocorticoid receptor resistance. This means they fail to respond to cortisol's anti-inflammatory signal, leading to a paradoxical state of chronic inflammation. Next, let's explore the key players in this chronic inflammation, the pro-inflammatory cytokines. Chronic low-grade inflammation in depression is marked by elevated levels of inflammatory mediators, specifically IL-6, TNF-alpha, and IL-1-beta. These cytokines activate pathways like NF-kappa B, sustaining the transcription of inflammatory genes, which suppresses the adaptive immune system's efficiency. The immune system's shift also directly impacts neurochemistry through the tryptophan-kynurenine pathway. Inflammatory cytokines activate an enzyme called IDO, diverting tryptophan away from producing serotonin, a neuroprotective compound, towards kynurenine. This pathway creates toxic downstream metabolites, like quinolinic acid, which is neurotoxic, thereby weakening both antiviral and anti-tumor immunity. Depression also severely impairs the body's frontline defenses, the innate immune system, and cellular function. Natural killer cell cytotoxicity is reduced, lowering the clearance of infected cells and weakening the immune surveillance necessary to fight early cancer cells. Oxidative stress and mitochondrial dysfunction lead to energy-deficient immune cells, which impairs T-cell activation and accelerates immune aging, a process called inflammaging. These aren't just acute signals. Depression causes long-lasting, deep-seated epigenetic changes in immune cells. DNA methylation and histone changes result in a long-term pro-inflammatory bias and reduced immune adaptability, maintaining vulnerability even when mood symptoms improve. Chronic inflammation drives DNA damage and promotes immune escape, which is why depression is linked to worse cancer prognosis and reduced response to immunotherapy. Finally, the entire system is destabilized by disruptions in the gut-brain immune axis. Depression causes dysbiosis and leaky gut, allowing toxins to enter circulation, leading to systemic inflammation and further stimulating the HPA axis in a destructive, self-reinforcing loop. The integrated model shows depression induces a biological triad of chronic inflammation, immune suppression, and metabolic dysfunction. Understanding this means that treating depression can improve vaccine responses, infection outcomes, cancer survival, and overall mortality. View depression as a systemic inflammatory disorder. This critical shift in perspective is key to developing more effective and holistic treatments.